Good morning, students. Today we will discuss CPU scheduling, and in this lecture we will discuss first come first serve scheduling algorithm. Now, in single processor system, there is only one process which is running at a time, and any other must wait until the CPU is free and can be rescheduled. Means if some other process wants to execute, then it has to wait. In single processor system, only one process can execute at a time. So what is the problem with a single processor system is, or single process system is, that after completing the execution of the currently running process, the CPU becomes idle. So here comes the concept of multiprogramming system. Now in the case of multiprogramming system, we have multiple processes running simultaneously. Now, in the case of multiprogramming system, the utilization of CPU is maximized. Now, this process is executed until it must wait. Now, typically for the completion of some input-output request, okay, means process is executing or in waiting state. If a process is in waiting state, means it is waiting for some input-output operation to be performed. In multiprogramming, we try to use the time productively. Means several processes are kept in memory at one time, and when one process is waiting, then the operating system takes the CPU away from that particular process and gives the CPU to some another process, and this pattern continues. Now, a process is in one of the two states. It is either in CPU execution state or in input output waiting state. Basically, a process execution begins with the CPU burst, and after that we have IO burst, which is further followed by CPU burst, and after that IO burst, and so on. Now, what is CPU burst here? CPU burst is when the process is being executed by the CPU. Means CPU is executing some process, then we say it is an CPU burst. And if the process is performing some input output operation, then we say that process is in IO burst state, right? Now we have two types of scheduling: primitive scheduling and non-primitive scheduling. Now, whenever the CPU becomes idle, then what happens, that operating system selects some process from the ready queue, and this selection procedure is carried out by the short-term scheduler or CPU scheduler, right? And the scheduler selects the process from the processes in the ready queue, and it allocates that process to the CPU so that it can be executed by the CPU. Now next term we have dispatcher. Dispatcher is the module that gives control of the CPU to the process that has been scheduled by the short-term scheduler or the CPU scheduler. Next we have dispatch latency. Now dispatch latency is the time it takes for the dispatcher to stop one process and start another running process, right? Next we have, there are four circumstances under which the CPU scheduling decisions may take place. Number one is when a process switches from the running state to the waiting state. Means some process is running and it has to perform some input output operation. Then what happens is that it goes to the waiting state, right? Second situation is when the process switches from the running state to the ready state. And this situation occurs when some interrupt occurs. So the interrupt may be either input output interrupt, or it may happen that some higher priority process comes in between to execute, right? So any kind of interrupt may be there. Third one is when a process switches from the waiting state to the ready state. And finally we have when the process terminates. Now as you can notice here, in the case of first and fourth, there is no choice but to select another process from the ready state. Because if some process terminates, then obviously we cannot execute that particular process because that process has been terminated. Then it is a compulsion to take another process from the ready queue. Similarly, in the first case, when some process is running and it goes to the waiting state, now then obviously we cannot execute that particular process. Now it is a compulsion to take another process from the ready queue, right? But in the case of second and third, there may be a choice. Okay, so when scheduling takes place only under circumstances 1 and 4, then we say that the scheduling scheme is non-preemptive or cooperative. Otherwise, we say that the scheduling is preemptive. So that's all for now. Thank you so much. In the next lecture, we will discuss the scheduling criteria. Thank you.